How does connection pooling boost Python database performance? Imagine trying to get a drink at a busy cafe. If every time you wanted a beverage, the barista had to make a new one from scratch, it would take forever. Now picture a setup where the barista keeps a few drinks ready for quick pickup. That's similar to what connection pooling does for Python applications talking to databases. When a Python program needs to access a database, it normally has to open a connection. This process involves network communication, checking credentials, and allocating resources. It can take a lot of time, especially if it happens repeatedly. Connection pooling keeps a set of open connections ready to go. When the program needs to run a query, it simply borrows one of these ready-made connections instead of creating a new one. After the query runs, the connection is returned to the pool, waiting for the next request. This reuse cuts down the time it takes to get data and speeds up the whole process. Another big benefit is resource management. Databases can only handle a certain number of connections at once. Without pooling, opening many connections at the same time can overwhelm the database, causing slowdowns or crashes. Connection pooling limits the number of active connections. It shares these connections among many users or parts of the application. This way, the database isn't overwhelmed, and everything runs smoothly. This setup is especially helpful when many users are accessing the application at the same time or during traffic spikes. Web applications or data dashboards often see lots of requests. Connection pooling helps these apps stay responsive without creating too many connections that could slow down or crash the database. In Python, libraries like Alchemy make it easy to add connection pooling. They include classes like QPool that manage the pool of connections automatically. For asynchronous programming, libraries like Async provide connection pooling that works with Python's async and await features. This allows non-blocking database access, which is perfect for scalable apps. Using connection pooling results in faster queries because the application doesn't waste time opening and closing connections. It also reduces the load on both the application and the database server. This makes the app more scalable, so it can handle more users without performance drops. Plus, it improves stability because the database isn't overwhelmed with too many connections at once. To get the most out of connection pooling, developers should set the pool size based on how many connections the database can handle and how many users they expect. It's also important to handle errors properly and keep an eye on the pool's performance as the app grows. In short, connection pooling is a simple yet powerful way to make Python database interactions faster and more efficient. It keeps your application responsive and ready to grow without putting too much strain on your database.